Hey, good day, everybody. Today we're going to talk about constructing triangles. So, first off, let's talk about the triangle sum theorem. What this means is that the sum of the angles in a triangle is 180 degrees. Now, it may sound difficult, but it really isn't. What you simply do is take your angles and add them up. 60 plus 90 plus 30. That equals 180 degrees. Therefore, that means it's a triangle. Let's look at some examples down here. I'm going to put this as 1, 2, and 3. Let's look at example number 1. Is example number 1 a triangle or not? Count the sides up. 90 plus 45 plus 45 equals 180 degrees. By the triangle sum theorem rule, it's a triangle. What about number 2? Let's add them up. 80 plus 25 plus 75. Is that a triangle? Well, I know 75 plus 25 is 100, and 100 plus 80 is 180. So that means these three angles would make a legit triangle. All right, let's look at one more. 60, 60, and 50. 60 plus 60 plus 50. 60 and 60 are 120, plus 50 makes it 170. Is that equal to 180? It's not. So therefore, by the rule of the triangle sum theorem, this cannot be a triangle. It's that simple. All three angles, when added together, have to make 180 degrees. If they don't, it's not a triangle. Not a triangle at all. So note, if you know the measure of two of the angles of a triangle, you can find the measure of the third triangle by subtracting the sum of the two angles from 180 degrees. If you do that, if you add up your two angles, subtract it from 180, it will give you the missing number. Think of it like this. A plus B plus C equals 180. And A, B, and C are all angles of the triangle. And it could be whichever angles you want on there. It doesn't have to be specific. But that's what it looks like. So let's look at an example down here. What's the measure of the third angle? Excuse me. If I have one that is 42, the other one is 74, if I add those up, what do I get? I have 6 and 11. 4 plus 2 is 6, and 7 plus 4 is 11, so it's 116 degrees. Now if I take 180 and I minus 116, what do you get from there? What do you get when you take 180 minus 116? You should get 64 degrees. That means this angle right here is 64 degrees. See? Pretty simple, right? Okay. Let's look at another theory or theorem. The triangle inequality theorem. What this states is that the sum of the lengths of any of any two sides of a triangle is greater than the length of the third side. Now, cut us off here. There should be a number 7 right there. Okay, so let's try it out. Let's see what happens. 4 plus 4. That equals 8. Is 8 greater than 7? It is, right? All right. 4 plus 7 equals 11. Is that greater than 8? Yep. And then there's another 4 plus 7. We know it's 11, and it's greater than 8. So, in all three versions, it works. And then, therefore, that means that this is a triangle. If it helps, let me show you with this red color here. What you want to do is you want to add that side up. You want to add these up. And let me choose one more color. How about purple? And you want to choose, or to add these up. Okay? Now, let's get back to my blue pen. Okay. So given the side measures, or can the given side measures form triangles? Let's see. We're going to call this 1, 2, 3. So on example number 1, 3 plus 5 equals 8, right? Is 8 greater than 4? It is, right? 5 plus 4 is 9. Is that greater than 3? It is. And 3 plus 4 is 7. Is that greater than the 5? It is. So yes, triangle number 1 can be a triangle. What about example number 2? 1 plus 5. That is 6. Is 6 greater than 3? Yep, it is. So we're good there. What about 5 plus 3? That's 8. Is 8 greater than the 1? Yep. What about 1 plus 3? That's 4, right? Is 4 greater than the 5? It's not. So no, because 1 plus 3 is equal to 4, and that is less than 5. So that is a no. Now let's look at example number 3. Can it be a triangle? 6 plus 6 is 12. Is 12 greater than 5? Yes. And this 5 goes down here. What about 6 plus 5? That is 11. Is that greater than 6? It is. And then this 6 plus 5 is 11, and that's greater than the other 6. So yes, that can be a triangle as well. A little review. Review what we already know. Classifying triangles by angle measures. One 90-degree triangle, a triangle with one 90-degree angle is a right triangle. If you have one obtuse angle, something that's greater than 90, that means you have an obtuse triangle. And if you have all the angles are less than 90 degrees, it's an acute triangle. If you want to classify by side lengths, if all side lengths are the same, it's equilateral. If all side lengths are different, it's a scalene. And if two of them match, that means it's an isosceles. With the constructing triangle videos, we're going to skip over and we'll try to do number 3. What we can do is we can use a ruler to draw a line segment of any length, since it's not specific, and then use a protractor to construct a 50-degree angle at any point on the line. Then use a protractor to construct an 80-degree angle using another endpoint of the line. Extend the line segments you drew in 2 and 3 until they meet. You can use a protractor to verify. So I'm going to kind of freehand this, but what we're doing is this. We're going to draw a line segment. And then I'm going to use a protractor, and I'm going to draw a 50-degree angle. And then I'm going to draw a 80-degree angle. And then what I do is I extend the lines until they meet. And this is where they meet. Now excuse me. Now classify the triangle by angle and by its side length. First off, let's look at the angles. Remember our angle sum theorem. A plus B plus C equals 180 degrees. If I have 50 plus 180, 50 plus 80. 50 plus 80 plus C is equal to 180. What is C? Well, 8 plus 5 is 130. So that means C has to equal 50 degrees. Okay? So, if I do that, let's look at the measurements. I have three angles. Are there equal angles? Are there no angles that match? What do we have here? We have two angles that match, right? So if we have two angles that match, let's go back over here. What does this say right here? Let's look at the angle measurements. All acute angles is less than 90 degrees. It's going to be an acute triangle. So we know that we're at an acute triangle, right? All three are less than 90. Now, if we have two acute angles, what that means is we're going to have matching side lengths. Because these two angles match, then these two sides are going to match. And if those two sides are going to match, what kind of triangle do we have? Let's look here. Side lengths. Two side lengths the same. It's an isosceles triangle. Isosceles triangle. So you have an acute isosceles triangle. Okay? All right, folks. You have an exit slip to look over. Try your best at it. If you have problems, let us know. If you pass it and you're good to go ahead and go to homework. If y'all have any questions, please get in contact with us.